All right, my children, it's time to talk about your second quiz warm up. It's on the page that looks like this. It says it at the top. I'll probably tell you a page number on Schoology or something. I don't really know how Schoology works yet, because as we've discussed, for current me, it's July. So, the future me will probably be able to tell you something about that. Either way, current me can definitely talk to you about this warm up. So let's do it. Except when I say let's do it, what I really mean is you need to pause this video and try it by yourself, like a grown up or a chemistry student. Pause the video, try the warm up, then come back and play the video. I'll wait. Did you pause it? Did you do the whole page by yourself? Did you at least try to do the whole page by yourself? Did you even read all of the questions? Thank you. Let's go over these problems. Number one, it gives you a list of stuff and it asks which ones are chemical compounds, not elements. Now, we know that elements are found on the periodic table. So if you check your periodic table, you can find most of these things. Iron's on the periodic table, it's Fe. Chromium's on the periodic table, it's Cr. Radon is on the periodic table, it's Rn. And silicon's on the periodic table, it's Si. Now, no matter how hard you try, you will not be able to find water or ammonia on the periodic table because they are not elements. Water, hopefully you know this, is H2O. Notice by the fact that there are 2 capital letters there, that makes that a compound. And ammonia, you don't actually know what ammonia is. I don't expect you to know what ammonia is, like on a chemical basis right now, but I do expect you to be able to figure out it's not on the periodic table. I'll tell you, ammonia is NH3. Again, 2 capital letters. You don't have to like memorize that that's what ammonia is. That's not really the point of this question. The point is it's not on the periodic table, therefore it's not an element. So your answer choice for which ones are compounds, D. Number 2, an example of a heterogeneous mixture is, and then it's got 4 answer choices. Let's recall what a heterogeneous mixture is. That is when you have a whole bunch of different substances mixed together, and that hetero prefix at the beginning means that there are visible differences within the mixture when you look at it. So you can like actually see this part is different from that part is different from that part when you look at it. That tells you it's a heterogeneous mixture. So let's look at these answer choices. We got gold, which, hopefully you kind of know this just from thinking about it. There's no visible differences when you look at gold. So even if it's a mixture, it wouldn't be heterogeneous. But also if you check your periodic table, gold's on there, which tells you gold is an element and therefore not a heterogeneous mixture. The other super easy one to get rid of here is water, because as we just talked about, we know water is H2O. And again, those 2 capital letters, that tells us that's a compound. A compound is a pure substance. It's not a mixture. It therefore cannot be a heterogeneous mixture. That's not our answer choice. Now we're left between brass alloy and fruit salad. Again, if you think about what that prefix hetero means, and that it means that when you look at it, you can see parts that are different. If you kind of know what brass looks like, then that should tell you like, well, fruit salad, I definitely know there's differences. I can like see a cherry or a melon or pineapple or pears or like whatever you put in your fruit salad. There are different things I can see when I am looking at it. So that tells me fruit salad, if I see differences, that is a heterogeneous mixture. But even if you weren't sure about fruit salad, this word alloy in our other answer choice, that is a vocabulary word that we learned. All alloys are homogeneous mixtures. In the case of a brass alloy, it's a mixture of copper and zinc, but they're mixed together so well that all of it looks the same to your naked eye. You need a microscope if you're going to get in there far enough to see the differences. And if you cannot visibly see differences, then it's well mixed and it's a homogeneous mixture where all of it looks the same. which is how we confirm that brass alloy is not the answer choice we're looking for. And what we wanted for heterogeneous was the fruit salad. Number 3, an unknown impure white liquid was filtered. No signs of chemical reaction occurred. After filtering, the filter paper held white particles. The catching beaker contained a clear liquid. What type of substance was the original liquid? Well, this word impure is really important because that word impure tells me, is it going to be, basically which side of my flow chart is it going to be on? If we go back on our notes to that flow chart, scroll. Go. Oh, I just realized it's going to be sideways in the program that I'm using. That's fine. We'll figure it out. See, it's sideways. That's fine. It's fine. Pure substances are element and compound, and that implies that a mixture would be impure. Whoa. So if we think about the definition of a pure substance as being either an element or a compound, then looking at this question and seeing that it tells us it's impure, that knocks out 2 of our answer choices right there. Elements and compounds, those are pure substances. The question says it's impure. That means neither of these could possibly be the answer. It cannot be an element. It cannot be a compound. It's got to be a mixture if it's impure, and vice versa. Impure has to be a mixture. Pure has to be either an element or a compound. So if we see the word impure and we know that that means mixture, then now we have to decide about this homogeneous or heterogeneous question. So we look again and it says that they filtered it. Filtering, remember, is a type of physical separation, which again is something you can only do, like that's the only way you can separate. Let me rephrase. Physical separation is the only way you can separate pieces of a heterogeneous mixture. Physical separation won't break apart an element or a compound. So that's actually another clue that they're using filtering. That's another clue that this is one of the mixtures. And when we look, after filtering, the filter paper held white particles. The catching beaker contained a clear liquid. That means they were able to separate different parts. So when we think about if it was originally homogeneous or if it was heterogeneous, there were separate parts that they were able to filter. And oh my gosh, the tablet just went to sleep for some reason. There, it's back. We're fine. So we're able to filter out different things. We can see that there were differences. That tells us that originally it was a heterogeneous mixture. Let's look at number 4. How is a mixture different from a compound? Particles of a mixture are combined chemically. Components of a mixture can only be separated chemically. Components of a mixture can be separated by physical means. Composition of a mixture may be constant. Okay, some of this is just knowing definitions. Particles of a mixture are combined chemically. That's not true. Particles of a mixture are combined physically. They were combined chemically, that would form a compound, and then it would not be a mixture. It would be a pure substance, a compound. Components of a mixture can only be separated chemically or only separated by physical means. These 2 answer choices are opposites, which is probably a clue that it's probably one of those, because it can't be both of them if they're opposite each other. Let's come back to it though. Let's look at D. Composition of a mixture may be constant. That's not true for mixtures. That's true for compounds. The whole point of a mixture is there's a whole bunch of different stuff in there, and constant meaning it's all the same stuff inside of it. That's not true for a mixture. That's true for elements and compounds. So it's not D. So it definitely is one of these 2 things that happen to be opposite each other. So you just have to know your vocabulary, which one's true. Are components of a mixture separated chemically or are they separated physically? Well, chemical separation is what we talk about for elements and compounds, because you can only get those pieces to separate into what they're made out of using a chemical reaction. That means it's not B, it's going to be C. Number 5, which words best describe a pure sample of glucose C6H12O6? That word pure does tell us it is a pure substance. If it's a pure substance, it cannot be a mixture. So it's not going to be Roman numeral 2. Then you have to decide it can't be both an element and a compound. It can only be one or the other. Remember, an element would have only one capital letter, and a compound would have 2 or more capital letters. So if we look at that formula they gave us, C6H12O6, that's 3 capital letters, that's a compound. So when we look at the answer choices, 1 and 4 is an answer choice. Answer choice D is our correct answer. Let's talk properties. I'm going to go through this chart like this column all the way down first, and then I'll come back and do the second column all the way down. Okay. Let's just talk physical and chemical. The mass of a cup of water is 50 grams. Chemistry booklets are orange. Arsenic is toxic. Gold is malleable. Iron can experience oxidation. When we're talking physical and chemical properties, remember physical properties, when you observe them, the identity stays the same. Chemical properties, when you observe them, to observe the property, you have to change the identity of the thing. So keep that in mind. If I measure the mass of a cup of water is 50 grams, is it still a cup of water after I measure those 50 grams? If yes, if it keeps the same identity, that tells me this is a physical property. The mass is a physical property. Chemistry booklets are orange, the color there being the property we're talking about. If I look at a book and I say, oh yeah, that's orange, did I turn it into not a book or not orange or not paper? No, it's still all of those things. Me looking at it and saying, yes, that's orange, that observation did not change what the book is made out of. So that tells me that if it kept the same identity when I observed it, that's a physical property. Arsenic is very toxic. If you poisoned something, or if something was poisoned by arsenic, we've talked about toxicity where that actually changes what your cells are doing. Like it causes chemical reactions in your cells that ultimately end up causing you to act poisoned, which usually involves like vomiting and diarrhea and blood coming out of places. It's gross. Anyway, toxicity, the only way that you can observe if something is toxic is to see if it poisons something. And when an organism is poisoned, its cells will change. And there will be chemical reactions in its cells. There will be identity changes that makes it a chemical property. Gold is very malleable. That property there is malleable, which that's the one that means like you can hit it with a hammer and it'll change its shape. It'll like bend or dent fairly easily if something is malleable, like clay or gold. That's the reason when you play Minecraft that all the gold tools like suck. They break immediately because gold is super malleable. They're just not strong enough to keep being a tool. Malleable, if I can check that something's malleable and it stays being the same identity, if I can check that gold is malleable and it stays gold, that tells me it's a physical property. And yeah, if I reshape a bar of gold into something else, it's still going to be gold. That tells me malleable is a physical property. And the last one, iron can experience oxidation. Oxidation is a type of reaction. We talked about this. It is basically a fancy word that means rust. When iron rusts, it stops being iron. It starts being iron oxide, which is a compound and is rust. It's not the same stuff. So if it has changed its identity, that tells you it's a chemical change. Now let's talk about this intensive, extensive half of the chart. Intensive properties are independent, intensive, independent of how much matter there is. Extensive depends on matter. And we talked about 3 main extensive properties, where basically if I have more stuff, the value changes. We talked about mass, length, and volume. If I have more stuff, it's going to weigh more. If I have more stuff, it's going to be longer. If I have more stuff, it's going to take up more space. That's what that means when we say mass, length, and volume are extensive properties. So we look at these. The mass of a cup of water is 50 grams. Mass, oh, we just wrote that down, is an extensive property. If I had more water, the cup of water would weigh more. So if I have more stuff and the value changes, that tells me that's an extensive property. The chemistry booklets are orange. It doesn't matter if I have 1 booklet or if I have 50 booklets, they're still going to be orange. No matter how much stuff I have, the color stays the same. That tells me color is an intensive property, independent of how much matter there is. Arsenic is very toxic. It doesn't matter if you have a little bit of arsenic given to an organism or if the organism takes a whole bunch of arsenic, it's still going to poison the organism. So if it's independent on how much stuff you have, that tells you this property is intensive. Gold is very malleable. Again, it doesn't matter if you have like 1 piece of gold jewelry or if you have a big old gold bar, the gold is still going to be malleable. If it's independent of how much gold you have, that tells you it's an intensive property. And iron can experience oxidation. Again, rusting. Any amount of iron can rust if it gets exposed to water. So, and oxygen. So it doesn't matter, again, if it's like 1 little screw or if it's a whole building. If you have iron in the right conditions, it is possible for that iron to oxidize. So if it doesn't matter how much you have, if it's independent of the amount, then that makes this an intensive property. All right, coming down, match the following substances with the correct type of matter. You can use something more than once. Notice there's 5 blanks, but there's only 4 things in the word bank. So yeah, you're going to have to reuse at least 1 thing. These are all we're classifying. Is it an element, a compound, a homogeneous mixture, or heterogeneous mixture? Again, you have that flow chart in your notes that helps you decide how these go. The quickest thing to look for, the fastest, would be check if you're given any formulas. Like this first one, here's a formula. There's only 1 capital letter. If there's only 1 capital letter, that should tell you that this is an element. Okay, the next one, again, they gave you a formula, and this one has 3 capital letters. If there's more than 1 capital letter, that should tell you this is a compound. Same thing on number 8. Don't let the word ice confuse you. Ice is just solid water, H2O. And that, again, there's more than 1 capital letter. That's a compound. Number 9 and number 10 get a little trickier because you were not given a formula, a chemical formula. So you have to like actually think about it a little bit. Number 9 says bronze alloy, and then it mentions copper and tin, but they're not like, it doesn't say CuSN together as a chemical formula. If it was written like this, that would make it a compound. But it's not written like that. It's written with just this and sign here because it's trying to tell you they're mixed together. So it's one of these mixtures. And again, we've talked about alloys as one of our vocabulary words. You should know that an alloy is a type of homogeneous mixture. I'm just going to abbreviate homog mix. And then pizza. Hopefully off the top of your head, you're able to be like, oh, pizza's not an element. Pizza's not a compound. It's got to be one of these mixtures. And again, think about what these prefixes mean. Homogeneous means that if you look at it, it all looks the same. Heterogeneous means that if you look at it, there are different parts you can see. With pizza, does every piece of pizza look the exact same as every other piece of pizza? Does every part of a piece look the same? No. A slice has visible differences. It's got crust, it's got sauce, it's got cheese, it's got toppings. It looks different. So pizza is a heterogeneous. Oops, that's not how you spell. heterogeneous mixture. And finally, number 11, what is the density of a substance that weighs 105 grams and has a volume of 83 milliliters? Show your work. Well, you know the density is mass divided by volume. They've given us a mass that says weighs 105 grams. That's your mass. And has a volume of 83 milliliters. So that's your volume. Stick that on the bottom. Showing your work just means like, tell me what you're plugging into your calculator. Don't just write a number down out of nowhere. Tell me what you're putting in your calculator. And again, this math is simple enough. You can use your phone calculator if you want to. We'll talk about how to do more complicated math on your computer when we get to more complicated math. But yeah, you can just do it on your phone and, oh, look, 1 point rounds to 1.27. You do need units. The mass was grams and the volume was milliliters. So this ends up as grams per milliliter as our density units. So there you go. That's your warm up. Good luck on your quiz. You can watch this video more than once if you need to before you take the quiz, or just rewatch the part that is confusing you if you need to before you take the quiz. You got time. But yeah, just good luck. Go take your quiz. Have fun.